Thanks for joining me. In this video, we will be doing a few examples of application problems related to logarithmic and exponential functions. So some of these should look familiar. You'll have some similar to this in your homework. Many of them relate to earning interest. And so the first two examples we'll do are going to be problems like that. And then I have another one that's just similar to another one in your homework. So for the first one, we deposit $4,500 in an account that earns 3.5% interest compounded continuously. The first thing you want to do when you're doing something like this is look at the compounding. So if it's compounded continuously, there's one formula. If it's compounded any other way, it's a different formula. So the continuous compounding formula is A equals P times e to the RT. A is the amount in the account at the end of the time period. P is the principal, or the amount in the account at the beginning, so the original amount. E is a number. It represents 2.71-ish. R is the interest rate as a decimal. And T is the time, how many years pass in your scenario. So give a formula to represent the amount of money you will have after T years. So that means we're going to have A and T left as variables in our equation. So we will have A equals, the principal we know is $4,500 times E to the RT. So the interest rate is 3.5%. If we divide that by 100 or move the decimal over 2 times to the left, we'll get 0.035. So that will be 0.035 times T. So there's our formula. We're going to use that formula for the remainder of number 1. So B, C, D, and E, to answer those, we will use the formula from part A. So part B, how much money will you have in the account after 8 years? So 8 is the years, so that's going to go in for T. So this is a very straightforward application of using the formula. So you would just plug in 8 for T and put that in your calculator. So 8 times 0.035, raise that to the E, and then multiply by 4,500. And you will see that you get $5,954.08. So it doesn't tell us how to round, but anytime you're doing a problem involving money, you always round it to the nearest cent. So it was 0.084, so the 4 makes the 8 stay an 8. It doesn't go up to a 9. So 59.54 and 8 cents. Part C is how much interest will you have earned. So you have the amount in the account at the end of 8 years, and you know how much you deposited, so you simply subtract those to find the amount of interest, whoops, that's a 0, that you earned. Okay, so minus 4,500, I get $1,454.08. So part B and C, we've probably done that before in an earlier section. D and E are the ones that are going to be different. This relates to the exponential and logarithmic equations. So part D is, how long will it take for your account to reach a balance of 6,000? So notice this time they're giving us the A, so we're going to plug in 6,000 for A, and when we do that, we're going to be left with the T. The T is in the exponent, so this is an exponential equation. Remember to solve exponential equations when it just has one exponential expression within your equation. You want to get the exponential expression by itself and then rewrite in log form. So let's identify the exponential expression. The base is e raised to the 0.035 t power, so that's what we're trying to get by itself. So to do that, I need to get rid of that 4,500. Since it's multiplication, I will undo it with division. So when I do that, I will get, let's see, what's 6,000 divided by 4,500? So it doesn't divide evenly, so let's reduce it. So 6,000 divided by 4,500, that'll be 60 over 45. Divide by 5, I will get 12 over 9. And then divide by 3, I will get 4/3. Okay, so this is 4/3 is equal to e to the 0.035t. So I've got my exponential by itself. So at this point, what I want to do is rewrite it in logarithmic form. So identify the base. The base is e. Since the base is e, we will use the natural log. So natural log base e of 4/3, go across the equal sign, is equal to 0.035t. And now the last step to solve for t is to divide by 0.035. So we will get t equals the natural log of 4/3 over 0.035. And if I want to know what that is, since it's years, let's see what I get if I put it in my calculator. So when I put that in my calculator, I got 8.22. So we can say a little over 8 years. In part E, we have how long will it take for your account balance to double? So you can see that we're still trying to find the amount of time. But this time it doesn't give us a number. It just wants to know double. So what we want to do is look at and consider the original amount. So originally we deposited $4,500. So double means times 2. So we want to know, when will the new balance be double the original? So 2 times 4,500 is 9,000. So we're going to plug in 9,000 for the end amount. So it's going to be the same process as part D, just instead of the 6,000, we'll have 9,000 there instead. So we will divide by 4,500, and we will see that we get 2 is equal to e to the 0.035t. We will now rewrite in log form. So log base e of 2 is equal to 0.035t. We will divide by 0.035. So we will get t is natural log of 2 over 0.035. And then if we want to know the years, we will put it in our calculator, and we will get 19.80. So 19.8. So approximately 19.8 years to double. Let's look at number 2. So number 2, you deposit $2,000 in an account that earns 5% interest compounded monthly. So in number 1, we had compounded continuously. Number 2, we've got compounded monthly. If it's not continuously, then it's a different formula. So this formula is going to be A equals P times 1 plus R over N raised to the power of N times T. A is the amount at the end of the time period, P is the principal, R is still the interest rate, T is still the time, and N is the number of times it's compounded per year. So in this case, it's compounded monthly. That means N is going to be 12. 12 months in a year, so 12 times per year. This one, it doesn't have a bunch of parts. It just asks how long it will take. How long will it take for your account balance to double? So originally I had 2,000. that means in the end, I want to have 4,000. So 4,000 is the amount at the end, 2,000 is the principal, 1 plus, the interest rate is 5%, so that would be 0.05, N is 12, and T, oh, that's what we're trying to find. So that will be T. Okay, so you can see that we have an exponential equation because the variable is up in the exponent. So the first thing we want to do is get the exponential part by itself. So the 2,000, I can get rid of that first by dividing both sides by 2,000. So that will be 2 equals 1 plus 0.05 divided by 12 to the 12t. Notice that I don't have a variable in the parentheses, so I can go ahead and figure out what that is. So 0.05 divided by 12 plus 1. Okay. So I'm going to end up having to round it. So what I probably want to do is just recognize that this entire thing is the base. This is going to keep me from rounding. So this whole thing is the base. So I'm going to have log base 1 plus 0.05 over 12, whatever that number is. It's like 1.004166666, etc. So in order to keep me from rounding, I'm going to put that whole expression there as the base. Of 2 is equal to 12t. And then to solve for t, I'm just going to divide by 12. So I'm going to end up just putting all of this in my calculator, but the problem is I don't want to round in any of the intermediate steps or I'm going to get the answer wrong. So if I put this in my calculator, let's see what I get. I get 13.89, so a little over 13 years. So you'll have several in your homework similar to those, the compounding. Remember that if it compounds continuously, you will use the first formula that I showed you. If it compounds any other way besides continuously, you will use this formula. All right, in your homework you have a couple like this. It looks very overwhelming, but it's not as bad once you see how to do it. So I wanted to make sure I showed you an example like this. So the pH scale for acidity is defined by this equation. So pH equals negative log of H plus. So the thing to realize here, instead of coloring it all, let me just talk about this. The pH is one variable, okay? So that's X equals negative log H plus is a hydrogen ion, and that's just another variable, y. So really this is just X equals the negative log of y, and X stands for the pH level, and y stands for the concentration of hydrogen ions. So it's just two variables. It looks really confusing with the pH and the H plus, but it really is just X equals negative log of y. So if you know that, you're going to either have to be given the pH, which you would plug in for X, or you're going to have to be given the concentration of hydrogen ions, which you would plug in for Y. So if I look at part A, if there are 0.5865 moles per liter of hydrogen ions in a certain substance, what is the pH level of the substance? So it's asking you the pH level. So it means you don't know X. So Y, the hydrogen ions, the concentration of hydrogen ions is given to you. So you're simply going to plug that in. So X equals negative log of 0.5865. And all you have to do is plug that in your calculator and see what you get. When I did that, it doesn't say how to round. Let's just go to 2 decimals. So 0.23. would be the answer for x. So simple enough. If they give you the concentration of hydrogen ions, that's the easiest, of the two cases. You just plug it in your calculator and figure it out. Part B, if the pH level of a certain substance is 3.5, calculate the concentration of hydrogen ions of this substance. So in this case, they're giving you the pH, which is the x. So they're saying 3.5 is equal to negative log, and I'm just going to call it y. I don't want to put H plus. It's confusing. I know y stands for H plus. So now this is a log equation. So in order to solve this, I really want to rewrite it in exponential form, which means I need to get the log by itself. That negative in front is messing me up. So I'm going to divide both sides by -1, and that will give me negative 3.5 is equal to the log of y. The understood base is 10, so if I want to rewrite it in log form, I would have 10 raised to the negative 3.5 is equal to y. And now I can get my answer for y just by finding the answer to 10 to the negative 3.5. This one I'm going to have to round to more than 2 decimal places, otherwise it would look like just 0. So it's going to be 0.000316 228.